next speaker is an astronomer at the NASA Goddard Institute for Space Studies in New York City. And he's the co-organizer of this meeting. And he's cleverly arranged the program so that he would have the last word. Michael Wade.
It's not my fault. I blame Joe Patterson for putting the rest, which is convenient. Okay, so I'll try not to use this microphone. Okay, let's hope it stays away. So I wanted to pick a provocative title, of course. I thought that would keep people interested. I think we've had a lot of provocative talks, but not a lot of provocative titles. I don't think my talk will be quite as provocative as Ari's, but hopefully I'll get a few of you irritated by some of the things I have to say. So my original title, I didn't have a question mark, but I think after listening to all these talks the last 2 days, I better put a question mark after this. Because of course, there's a lot of things I learned, and I stayed up actually too late last night trying to adjust a few things so that I wouldn't have to repeat too much of what you heard. But there'll be some repetition, but I'll try to keep it to a minimum, and I'll skip over a few things as we go through. I think Hubble's known for three main things in the popular mind, and I think in most astronomers' minds, because we have to teach, astronomy 101 or astronomy whatever for the non-science majors. And when we go through our books, these three things come up. I think the first is confirming this island universe theory of Swedenborg, Wright, Kant, whoever you want to say came up with that theory, as Ayala told us on yesterday. The second is the classification of galaxies, or the classification of spiral galaxies, if you want to be a little more specific. And the third, of course, this expanding universe, which we touched on. And I think really there should be a much more focused conference on the expanding universe, especially after this discussion with Ari and people like that, but nonetheless. I think the key thing I want you to take away, and I think from my talk at least, and I think you will take away from everybody else's talks here in the end, is that none of these was discovered in a vacuum. None of these things were done in the way we're taught that science is done, in this linear fashion, and I'll come back to that towards the end of the talk. So let's first look at this island universe theory. So we've talked a lot about these people already. Henrietta Leavitt's published period luminosity relation for Cepheids, which is not highly cited, but again, something Peter Cole said yesterday made me think I should mention this. He said there was only 81 citations for one of these papers on Eddington's discoveries. But that's because ADS is woefully incomplete before basically the 1960s, and you can't get citations. They're not there. They haven't been done. So there might be actually 5,000 citations for that paper, but we don't know because no one's done it. It'd be a great text data mining project, but no one has tackled it yet. I'm going to talk to some text data mining friends of mine after this conference. As you were pointed out, Shapley makes the relation useful with his pseudo-parallax methods. I mean, sort of useful. And then a couple early papers I want to mention that I think are important for this theory. The first is a paper by Curtis in 1917 called Novae in Spiral Nebula and the Island Universe Theory. I don't think anybody's actually talked about this paper so far. But the point here is that he realizes there's a difference in the magnitudes of galactic novae in the spiral novae and then in spiral nebulae, and the galactic novae in our galaxy. And he assumes that if they're a difference in 10 in magnitude, they must be at least 100 times farther away. All right. Of course, he mentions that there's any kind of absorbing material that would have to be taken into account. But he's sort of promoting that island universe theory. That doesn't surprise anybody here who knows a little bit about Curtis. Okay. Maybe the next one will be a little bit more surprising. That's Shapley. Again, notes on the magnitudes of novae in spiral nebulae. It's the title of this paper. And again, he makes some assumptions, but in the end, he says if he uses the brightest stars, the minimum distance to the Andromeda, it's an order of 1 million light years away. Okay, this is already 1917, 2 papers by people, one of whom doesn't even believe in external galaxies, but is saying that maybe the Kappa-Teen universe is much larger than we realize. And he also, of course, mentions these problems with von Manin's measures of internal proper motion. He realizes very early on that that would be an issue with this model. Okay, another one, Lundmark 1919, and another paper by Luklau, Janssen, and Haar. I have to confess that I recently had them correct this reference. It was Laplace Janssen in ADS until last week, I think. It's been fixed up. A lot of citations for these people, at least for Lundmark, and not so many for this paper. But as was pointed out yesterday, there's the only problem with these novae observations that there was a supernova in the late 1800s in Andromeda, in the Andromeda Nebula, and people didn't understand at this time there was a difference between novae and supernovae, basically. So that was a bit of a problem, but still these two very big people thought that these novae observations were telling us something important. Another paper that I think was mentioned a little bit yesterday, just as an aside, is this fascinating paper by Öpik in 1922, the Estonian astronomer, who also makes some assumptions about what Andromeda is, and he comes up with a distance to Andromeda of about 1.5 million light years, 450,000 parsecs, remarkably close to the true value compared to some other things we'll see a little bit later. Of course, then there's the famous two Hubble papers. I mean, usually one's mentioned, but I think both are important. The paper in January in PASP, Cepheids and Spiral Nebulae, that's to M31 and 33, and he gets about 285,000 parsecs. And then, of course, this paper, 6822, NGC 6822, where he says the first object definitively assigned to a region outside the galactic system. So in this paper, he's a little more tepid. In this paper, he says, it is right. He gives these numbers. And he does reference, actually, Shapley for the Cepheid curves that he used to make the distances. So he got credit. In this case, he actually did cite somebody properly. Then there's this fantastic paper from 1927, Studies of Anagalactic Nebulae by Lundmark, where he says that Hubble 25 paper has shown a very nice agreement between the distances derived from Cepheids and from the novae. So I say from the novae. So he's saying that these novae are actually valid, and that refers to all of these previous references I gave you before. Okay, actually this paper will come back to us a little bit later. So the other big thing he's known for, of course, is this classification of galaxies. So let's talk a little bit about that history. So, as Ken Friedman talked a little bit in his talk, there's this gentleman named Reynolds. He wasn't maybe the first. There are many people who have thought about classification of galaxies. I can't be exhaustive in such a short talk, but I just want to mention this paper, which I think is really great. Photometric measures of the nuclei of some typical spiral nebulae, and he comes up with his own classification scheme, not so different from what Hubble and, as we'll see in a moment, Lundmark had come up with. Here's the Lundmark paper. There were actually two papers. One paper published in a Swedish journal. It's quite short. It's a summary paper, and then a paper that was published a year later by the Uppsala Observatory, which is much thicker. You cannot get it on ADS. Since I spent a lot of time in Uppsala, I was actually able to make a photocopy of the actual booklet, and I should try to find a way to get it on ADS. But regardless, he's one of these guys who's very good at citing his predecessors. He cites Reynolds' paper, Slipher, Hubble, Wolf, who we've heard about already, cited several times in this paper, and he says, of course, the classification of these nebulae based on photographic materials have been made by Bailey, Curtis, Miss Isaac Roberts, Wolf, Hubble, and others. The schemes of the three authors do not have any subgroups and serve for the purpose of a brief subdivision. And then he says, the classification suggested by me does not perhaps give very much more than the one by Wolf. I didn't have time to get Wolf's paper, and I apologize for that, but includes some forms which have no room in his scheme. How many people think Hubble would put that in a paper about classification of galaxies? I don't think he would do it. Okay, in that same paper, the short paper, he gives Hubble the credit for the term galactic nebulae, and he says among the anagalactic there are three subdivisions. So I think we're all familiar with these: globular, elliptical, spiral nebula, and then irregular chaotic forms akin to the Magellan Clouds. And what do those look like? I'll show you in a moment. Here's Hubble's 1926 paper. Again, spiral classification, very similar to Reynolds' 1920. Absolutely no reference to Reynolds' paper from 1920. Ken Freeman and David Block actually found correspondence with Reynolds and Hubble, and it's quoted in their fantastic book. And in this work, he references to Lundmark's work from the previous year and hits at plagiarism. I just have to read a little bit of this. He says, Lundmark, who was president of this Cambridge meeting, has since been appointed a member of the commission, has recently published his own classification, which, except for nomenclature, is practically identical to the one submitted by me. He makes no acknowledgments or references to the discussion of the commission, or then those for the use of the term galactic. It's a very strong statement in a publication. We're seeing a little bit of a spat going on here. So here's some meat to chew on. Lundmark, in that very large paper, which again is very hard to get, he replies. He says, this guy made an attack on me, written in such a tone I hesitate to give any answer, but he can't resist to give an answer. He says, I was at this meeting, I was not a member of the commission, so he could not have known about Hubble's paper. I didn't have any access to these memorandums. I didn't realize until a letter much later that he'd made another classification scheme. And I think the one that I think to the most is, as to Hubble's way of acknowledging his predecessors, I have no reason to enter upon this question here. So I think he was a little notorious, is what I'm getting at some level. Hence my title for my talk. Okay, here's Lundmark's classification: galactic nebulae, quasi-planetary nebulae, irregular nebulae. He gives some NGC numbers, and here's his anagalactic nebulae. Again, gives his own classification scheme, gives a bunch of NGC numbers, and of course, here is anomalous nebulae, globular, elliptical, elongated, lenticular, Magellanic nebulae, and then of course, the spiral nebulae. I blew this one up a bit more. Different degrees of compressibility towards the center. One branch spiral. Again, he gives his own classification scheme, and he gives examples, and on top of that, corresponding type in Wolf's system, okay? Same here. Corresponding type in Wolf's classification system. Very careful. This guy is methodical about citing people whose work came before him. Here's Hubble's. Looks very similar. You can see why Hubble was upset. Galactic nebulae and extragalactic nebulae. And then, of course, here's his spirals, and of course, he separates the spirals from normal and barred. And of course, he also gives very clear examples. No reference to other people's work in this paper. Now, when you read Block and Friedman's book, you find that they've been a little more clever in their investigations than some others of us have been in this room. They've been to the Mount Wilson Library, and they looked up Reynolds' paper from 1920 in the library that Hubble would have used, and they found in the margins of Reynolds' paper Hubble's classification schemes for his spirals next to Reynolds' classification scheme. Now, we don't know that Hubble wrote those in there, but it makes one a little suspicious who wrote them in and why they would write them in. It's a bit funny. And I want to just also remind people that this idea of the tuning fork really came from Jean's 1929 paper, as far as I know anyway. It did not show up in any of Hubble's works until this 1936 realm of the nebulae, where he actually populates out that tuning fork diagram. Okay, how about the expanding universe? We've heard so much about it. I'll try to go through most of it quite quickly. But just the people we've already talked about, of course, Slipher, Leavitt, Einstein, de Sitter's solutions, Slipher's radial velocities when they were coming out, Shapley's 1917 paper where he calibrates the Cepheid scale. Of course, Wiertz's work has been talked about from 21. Friedman's works from 22 and 24. Lundmark, this is, I think, one of the most beautiful papers from that period ever written. I can recommend it to anybody in this room and any graduate student to see how you should do observational astronomy. And one of my favorite things I mentioned in the first day of the conference is that I read some of these couple papers by Hilmar Durbeck and Walter Seiter from 1999 to 2001. And I think they may be the first people who actually tried to fit the data that Lundmark had put in that paper, and they got H0 numbers for all the wrong reasons, as John discussed just a few talks ago, between 44 and 100, if you can believe it. If you just fit the data to what is there, you get numbers of it, depending on how you fit the data.
Sorry, Mike, do you mean just for the nebula data?
Sorry, this is for the nebula data. Yeah, I'm talking about nebula data. I'm not talking about all the other things he fit, which is fantastic in itself. Okay, so that's why I recommend this paper. The Beers 24 paper was talked about, this log diameter versus velocity relationship, where again he cites Slipher's data, if you can believe it. And then of course the Stromberg paper, which actually people use the data in for their own papers and don't cite Slipher, but at least Stromberg did cite Slipher, although he didn't find much that was worth fitting in that paper. Now we've seen this plot before. This is Lundmark's plot of radial velocity versus distance. And I always like to say when I give another talk that's similar to this that it's probably the only time you're ever going to see distances in units of and distance to the Andromeda Nebula. And what I really like about this, I love to tell my students, show my students this plot, is that what astronomer wouldn't be tempted to fit a line to this data? I mean, I know we're sitting here like, oh, there's a lot of scatter here, but I don't know, when I was a graduate student, I saw lots of lines plotted through points that didn't look much more scattered than this. And they found all kinds of great correlations that were completely wrong. So I give Lundmark a huge amount of credit for putting this up, and he was so close, he could have done it, you know, but he didn't. He publishes a plot that's dying to have a line fit through, he doesn't do it. And Stromberg's paper from the year before, he plots it up for globular clusters, and he does it a different way. To make fun of the whole notion, he fits 2 different lines to the data, just to make fun of the whole idea. But this is integrity. I mean, you have to give these guys some credit for it. Okay, and we've talked quite a little bit about Lemaitre and all the things that he discovered, the 42 galaxies and his values of what we call H0 today. And he's very good about citing the previous attempt by Lundmark and Stromberg. And of course, the discussion about how parts of this paper were lost to the world, really until very recently. There was a paper by David Block in 2011 where he accused, or he had some kind of conspiracy theory idea that these numbers in the republished paper of monthly notices that we've talked about several times now were disappeared. He thought, well, something's going on here. I don't know what it is, but it's not, doesn't smell nice, you know. And I think most people agree that that was pretty much cleared up by Mario Livio with his paper last year in Nature. So I'll talk a little bit about those more in just a second, very quickly. But I also always like to show people the actual numbers from the Lemaitre paper. This paper, I got a copy of it about 6 years ago, and it was extremely hard to get the original copy of this paper because I couldn't find a copy in the United States of this Analyse Bruxelles Scientifique la-di-la-di-la, which was very frustrating. So luckily I have one of my best friends, he's Belgian. He called up a buddy of his at Louvain, and they went to the library and made a photocopy for us, scanned it in, and sent it to me. That's how I got it, and that's where these pages actually come from, is from that photocopy. This is another thing that should be put on the ADS, actually. So anyway, here are the numbers. Again, 625 kilometers per second per million parsecs. I won't go into where these numbers came from. I think we've already covered that, but I think we should at least see them in print once. Here's the paper by Bloch, A Hubble Eclipse, Lemaitre, and Censorship. What a provocative title. I would love if David had been here to give this talk. Whereas I mentioned before, he thinks it's very strange that those numbers I just showed you disappeared in the monthly notices paper, and then of course, Mario solves it. And I think this is really interesting from another way. This is also about doing historical research, because Harry and I had this discussion before, and Harry and Mario had a discussion about this, and Harry said, I was also trying to figure out where these numbers went between these 2 papers, and I think he wrote the Royal Astronomical Society and asked them if he could get some correspondence between Lemaitre and the editor, and they said there was no such correspondence. But Mario happened to be in England, I guess 2 years ago, and he actually went to the Royal Astronomical Society and says, let me see your correspondence, and he found it. And so Harry's lesson, I guess, is don't trust what people say, go there and see for yourself, and they actually don't have it. I mean, the same is here. I mean, not everything here is archived, right, as we discovered in the tour of the library. And I mean, Antoinette's an excellent librarian. I'm sure the librarians are also excellent, but they don't know all the correspondence because it's not all categorized. So what a surprise, in a sense. And it's kind of a relief that the Brits are not as organized as we think they are.
We were missing you in the Olympics.
Yeah, yes. Okay, there's of course the Hubble paper in 29. The Sinter paper, similar results, but again, understands GR in the context like Lemaitre. And of course, this 31 paper, where a lot of discussion about magnitudes and distances. He has a quote in the paper. I mean, again, I think Hubble was not consistent in his attributions to people, but he does say velocities previously available owing very largely the great pioneering work of V.M. Slipher at Lowell Observatory, but actually no citation to Slipher's redshifts in that work, that very important work. That's the second velocity distance diagram that we saw from before. And as was touched on before, the age of the Earth will become a problem with the H0 that he comes up with, as we know. Now, I really like this paper by Craig and Smith in 2003, where they try to figure out, you know, who does deserve the credit, if any credit should be given for this discovery of the expanding universe. And let's just read these. I mean, Friedman Since he gave no reasons why the universe should be expanding, he cannot reasonably be said to have discovered the phenomenon. I think we could have arguments with Ari about this for a while. But I do say one nice thing about that, the Friedman papers, is that at the end of, I forget which paper it is, and Ari will probably tell us which year it was, he does come up with an ad hoc number. He says, well, if the universe is this massive, then the age of the universe is around 10 to the 10th years old. It's the 22 or the 24 paper.
It is 22, but it computed a period of periodic world.
Yeah, but anyway, I mean, again, this kind of ad hoc thing put together in the way that Lundmark could have come up with the right number for all the wrong reasons. These numbers are, again, floating around there in funny ways. I like the quote about Lemaitre, insofar as Lemaitre did not establish observational universes, in fact, expanding did not make a discovery, but insofar as it gave theoretical as well as observational reasons for it, he discovered. And then, of course, Hubble must be considered the discoverer of this empirical law, but the law of receding galaxies is not the same as the expanding universe, a notion Hubble did not suggest in 1929, and in fact, very rarely ever suggested that he believed in the expanding universe, as we discovered. So, I think we should talk a little bit about making heroes, or the way that we think science is done. So there's, of course, this very famous quote. This is a little paraphrased quote from Kuhn, which is also mentioned in the paper I just talked about. There's a persistent tendency to make the history of science look linear or cumulative, a tendency that even affects scientists looking back at their own research. We always try to simplify what happened before. You know, if you ask your grandparents about what they did in their 20s, I'm sure you'll get a simplified picture of what actually went on. And of course, this goes along with Campbell's monomyth idea, this hero of 1,000 faces, this heroic figure that comes out of these works, but which was, of course, a much more complex scenario. And historians actually have, I don't actually know the exact title of this idea, but I think we may have presented with this evidence of the inevitability of the conqueror. I think that's what I would call it. You know, that Alexander the Great would have come along even if it wasn't Alexander the Great. The Macedonians were ready, they had the technology, they were just dying to get out and conquer the world, and Alexander just happened to be there. If it hadn't been, it would have been his cousin, or it would have been his uncle, or somebody else who would have conquered most of the known world at that time. And I think the same people feel, I mean, these particular branch of history feel the same about Genghis Khan and all these other great conquerors. The technology and the society was ready, and they were ready to move forward. Of course, most of us who read histories learn the opposite, that this great conqueror is the one who did everything. And that's how we end up, I think, these are all consistent lines of evidence in a sense, that we want to have our hero, and it's easier to write histories, and it's easier to write textbooks for first-year non-science majors to present this kind of very simple narrative. And I think that's what we need to think about, in a sense, is there a way for us to change either how the narrative is taught, or how we give attribution, or things of that nature. And I mean, if you think about something like the FLRW metric, you know, where you give 4 people credit for something, it's rather rare in science. If you think about it, most things get 1 person's name or 2 persons' name. But how many times can you think that more than, I mean, that 4 people's, it happens, there's a few cases, but it's very rare, right? So I think if we want to give, I mean, I think I'll wrap it saying, if we want to give Slipher more credit for this, we have to think about it in that context. As we discussed many times throughout this whole conference, that he didn't, you know, make the expanding universe possible or anything like that, but he contributed to it. And that's exactly what this FLRW metric is all about. It's, these people can contribute to making this thing a successful theory. And that's how we have to think about giving attribution to people like Slipher, who made these other theories successful, and how we can deal with that in the future. And I hope that, you know, when you're teaching your first-year students, whatever course it is in astronomy or whatnot, and you see something that's oversimplified, I actually write the writers of the books and tell them that this picture is too simple, and that students shouldn't get the idea that science is so linear and so simple, because it's not. It's not for any of us, and we all know that. Anybody who does science, anybody who does history knows that the narrative is not simple, and we shouldn't confuse people into thinking it is. If they want that, they can read bubblegum fiction if that's what they want. They shouldn't be reading nonfiction for that. And that's just a final slide with some books that I think touch on some of these different issues, and I thank you very much for your time.
Hearing this, pull something out of the back recesses of my mind. And that was hearing Walter Baade speak about Hubble and his background, that he came around 1920 to Mount Wilson with a very weak astronomical background. But he had an MA in astronomy, and his MA thesis, said Baade, was on the classification of nebulae. So he may very well have developed part of that well before Reynolds' paper was published. So it's something that needs to be investigated. Where he did that work, and whether a copy of the thesis is available anywhere would be very interesting.
It looks like David has the answer.
The answer is yes.
The answer is yes. Okay, excellent.
Readily available.
Readily available. So you find the classification in the thesis?
I don't remember. I don't think I ever read it.
Yeah, I think he uses Wolfsky.
He uses Wolfsky.
Yes.
So before, after Wolf, obviously. Yes. Okay. Does he attribute Wolf in this?
I don't remember it well enough.
Okay. Again, it's just this thing again that these things are all building upon each other. Okay.
Now, I have a second part of my comment, and that is that the first astronomer to have his picture on Time magazine was Eddington when he came to this country, and the second one was Harlow Shapley when he was going off to the IAU meeting in Paris. But Time magazine had a great deal of fun by having as their next cover Shapley June Harlow.
Fantastic.
Just, you know, a subtle hint.
Yes, sir. Yes, sir. Oh, Larry.
Other people must be very well aware of this, but in Gail Christensen's book, Edwin Hubble, Mariner of the Nebulae, he describes how Slipher was the head of an IAU commission when Hubble submitted his request to sort of wipe everyone else out in terms of the morphological classification of galaxies. There was some negotiation that went on at the level of the IAU. And I'm just wanting to bring that fact forward. And Slipher was a senior astronomer relative to Hubble, and he actually somewhat adjudicated this competition between people who were trying to definitively or get the position of having the definitive classification system.
How about in the back?
I was going to say, isn't the choice when you're trying to decide this is that most scientific discoveries are messy. E equals mc squared is unambiguous.
That's what I'm saying.
But we privilege Einstein because he gave the first correct explanation of photoelectric effect. Heinrich Hertz was the discoverer of photoelectric effect.
But when you learn Einstein in the textbook, you learn about Lorentz too.
Right.
Okay.
And
It's not as simple as it
no,
maybe
but
would
Lorentz
be.
didn't predict E equals mc squared. My point is, I'm not picking all relativity as the exception. You're saying that kind of thing where it's unambiguous or close to is the exception. And the rule is the discovery of spin is the rule. Where does Pauli get credit for saying double value? This is exclusion paper. Ullmann and Schmidt. Does Kronig deserve credit for making this? So forth and so on. It seems to be that most of the time it's messy. And you have to kind of decide how do you privilege if you privilege at all. One individual.
Absolutely, exactly what I'm saying. Correct.
But I think what makes it messy, messier than it need be, is when people confuse theory and experiment. I was delighted to see you finish with that lovely metric. But you're right to point out that's for theoreticians. I think there's been a thick debate going on this weekend, as everywhere else, between Hubble and Lemaitre. That's a ridiculous choice. That's a bogus choice.
That's exactly
Hubble
right.
is an experimentalist.
That's right.
I think you could definitely argue for a Hubble-Slipher law, an empirical law, just as you could argue for
An empirical correlation.
Yeah, but I do think, there's room, not only is there room for everybody, but, in terms of clarity of science and picking these things out, the first point is to, understand the difference between, for all of us, between what is a theoretical prediction and what is actually established later. And the ultimate example of that is about every 10 years somebody wins a Nobel Prize for establishing something that Einstein predicted. You know, it's incredible. You know, if you were to give him a Nobel Prize for each one of those, I'd say he'd be over 50 by this stage. You know, I've a point on the letter, but I'll wait till later.
Okay. David, you got a question?
Well, it's curious, and maybe you guys everybody can help. I'm not so sure I see in the data or in the examples you give, other than some classifiers acknowledge others, and other classifiers don't acknowledge anybody. Okay, it was. Can you say, number one, that there was acrimony or concern among the classifiers at the time? Was there a?
I presented evidence that there was.
That there was.
And and that's something I wanted to touch on, which I think we talked about last night in the bar, is this issue with citations. I mean, one thing I wanted to do for this talk for the last 4 months, and I never could pull it off, was actually go back into the literature and compare two people of similar reputation. 2's not enough, but it's better than 0, which is what I have right now.
Okay.
And I wanted to compare what Lundmark had done in terms of citations of people in papers he was writing and Hubble. And I don't have the empirical evidence to prove that right now, but my my sort of subjective feel, having read many papers of both of them, is that occasionally Hubble was very good about citing people and giving credit, and other times he was extremely bad at it. Like the 1929 paper, there's almost nothing in there. But Lundmark, if you look at his papers, he's almost uniformly very careful about citing his predecessors.
And he's an encyclopedist, and
Yes.
he was a wonderful one. And that is you might say that's a character trait, whereas maybe with Hubble it wasn't. I'm trying to expand the question though, because in 1904, okay, Edwin Frost was very worried because there were 23 systems of stellar spectral classification. And in order for people to talk to each other, and for the community to coalesce, there had to be a process through which there was adjudication and a decision to be made, and that's a long story. Well, here you have a similar thing. People realize that classification systems are not discoveries. They may lead to clues and that sort of thing, but they are, each one of them, idiosyncratic in terms of what somebody sees in a system. Did these people ever argue over what their classification system was revealing that others were not?
Oh, I don't think they did, because as we know, the classification schemes have been incredibly bad at predicting almost anything.
Yeah. So then I ask, what is the point of it? I mean, even I was quite fascinated with the stellar classification scenario that lasted from 1904 approximately to 1922 with the establishment of the Harvard system. But there didn't seem to be any strong possessive issues. There was maybe a little nationalistic pride in Vogel's system or whatever, but not much. And so
I don't have evidence that there was a lot of.
Well, but it would be curious as you look into it to see. I mean, were there any of these elements?
Hey, we're here to give you historians the fodder. We're here to give you the fodder for your next paper. Come on, because we can't do it right.
We're going to ask you to do it.
Okay, you can ask me to do it. Okay, I'm gonna just play one video, which I think we should end in a nice way here, if it lets me play it. I'm gonna quit this. I'm gonna try to play this.
I was a reasonably happy kid. I guess I was brought up in Brooklyn during World War II.
He's been depressed. All of a sudden, he can't do anything.
Why are you depressed, Robbie?
Tell Dr. Flicker. It's something he read.
Something you read, huh?
The universe is expanding.
The universe is expanding.
Well, the universe is everything, and if it's expanding, someday it will break apart, and that will be the end of everything. What is that your business? He's not doing his homework. What's the point? What is the universe about? We're here in Brooklyn. Brooklyn is not expanding.
It won't be expanding for billions of years, you know. And we've got to try to enjoy ourselves while we're here, huh?
So let's enjoy ourselves.